Hi guys, welcome back to my channel. I am Manoj, studying in Sri Venkateshwara College of Engineering, Department of Computer Science and Engineering, first year. Today we are going to discuss the topic Boolean network analysis. We are going to discuss the introduction, key concepts, application, benefits, consideration and future trends of Boolean network analysis. Introduction to Boolean network analysis. Boolean network analysis is a mathematical modeling technique used to study the dynamic behavior of complex systems, particularly in the fields of biology, computer science, and engineering. These networks are named after the mathematician and logician George Boole, who developed Boolean algebra, which deals with variables that can only have two values, true or false, 1 or 0. Key concepts. Boolean network. A Boolean network consists of nodes and connections between nodes, representing elements in a system and their interactions. Each node in the network represents a variable or a component of a system. The state of each node can be either 0 or 1, indicating an off or on state, true or false, or any binary distinct relevant to the system. Second is update rules. The behavior of Boolean matrix is governed by the update rules that determine the state of each node based on the state of its neighboring nodes. These rules are usually expressed in Boolean logic, specifying the conditions under which each node will switch from 0 to 1 or vice versa. Third one, the dynamics and state transitions. By applying the update rule iteratively, the Boolean network evolves over time, exhibiting dynamic behavior. The sequence of states that the network goes through is known as trajectory. Analyzing this trajectory can provide insights into the stability, attractors, and overall behavior of the system. Applications. Boolean network analysis finds application in various fields due to its ability to model and to study the dynamic behavior of the complex system using binary states 0 and 1. Here are some key applications of Boolean network analysis. Gene regulatory networks, GRNS, cellular biology, ecology and ecosystem dynamics, computer science, social network analysis, fault tolerance in networks. Gene regulatory networks. Boolean networks are extensively used to model gene regulatory networks where genes are represented as nodes and the interaction between the genes are modeled using Boolean rules. They help in understanding how genes regulate each other and how the system's behavior changes under different conditions. Cellular biology. Boolean networks are applied to study cellular process, signal transaction, pathways, and cell cycle regulation. They provide insights into the dynamic of cellular systems, including the identification of attractors representing stable cellular states. Ecology and ecosystem dynamics. Boolean networks are used to model ecological system and analyze the interactions between species in ecosystem. They help researchers understand how changes in one species or environmental factor can impact the overall stability and behavior of an ecosystem. Computer science. In computer science, Boolean networks are used to model and analyze the behavior of the digital circuits. They are also applied in algorithm design, particularly in the analysis of the algorithm with binary decision variable. Social network analysis. Boolean networks can be used to model and analyze social networks where individuals or entities are represented as nodes and relationship or interactions are represented by Boolean rules. This application helps in understanding the dynamics of the information flow, influence, and opinion formation in social systems. Fault tolerance in networks. Boolean networks are used to model and analyze fault tolerance in communication and computer networks. Understanding the robustness of a network under different failure scenarios helps in designing more reliable and resilient systems. Benefits: BNA offers several benefits, making it a valuable tool in various scientific and engineering applications. Simplicity and interpretability. Boolean networks use a binary state model 0 or 1, which simplifies the representation of the complex systems. The simplicity of the Boolean logic makes the model easy to interpret, facilitating a clear understanding of a system dynamics. Ease of modeling. Boolean networks are well suited for the modeling systems with discrete states where variables are either on or off. The modeling process is often more straightforward compared to the continuous models, reducing the complexity of the representing interactions with the system. Consideration. When consideration the application of the Boolean network analysis, there are several important factors and consideration to take into account. Nature of the system, sensitivity to model parameters, complexity of the interactions, validation and experimental data, stability and attractors, robustness analysis, biological relevance for biological system, integration with other modeling approaches, control and intervention strategies, computational resources, interdisciplinary collaboration, educational and communication aspect. By carefully considering these factors, researchers can make informed decisions about the appropriateness of using the Boolean network analysis for a given system and research question. It's often beneficial to approach modeling with a combination of techniques to capture the full complexity of real world systems. Future trends. Boolean network analysis, with its versatility and simplicity, continues to be a valuable tool across disciplines for understanding, modeling, and simultaneously the dynamics of a complex systems. It's important to note that the future trends in Boolean network analysis will likely be shaped by the advancement in computational technologies, interdisciplinary collaboration, and evolving needs of specific application domains. Researchers and practitioners in the field will play a very crucial role in driving these trends forward. Note: for the last developments, it is recommended to check recent literature and conference proceedings in the field of system biology, computational biology, and related disciplines. Thank you for watching.